Alright, cool. So I'm going to be talking about web apps with AWS Lambda, a bit about Lambda in general, but the main use case I'm going to cover is making web apps with them, because I think that's the coolest use out of it, the most practical for most people. So who am I? I'm Mitch, Grice. I real heart web apps and I real heart Python, but I angry face DevOps and I angry face managing servers. And usually they go hand in hand, right? If you want to make a web app, you have to put it on the web, and the web is a collection of servers and clients. Well, not necessarily. Modern technology is allowing you to do more and more abstracted things away from bare metal to VPS to containers, now down to functions. And what we're going to do is go right in at the very bottom level where you don't even care what machine is or what the operating system is or anything. You're just writing code. So a common setup for web apps is as follows. You have users. They send off a request. It hits a load balancer. The request goes from the load balancer to a series of redundant EC2 instances or compute instances. And then inside each of those compute instances, you have some sort of software, mainly and maybe Nginx. And then Nginx routes the request down into your actual code, which for this is going to be Python. And pretty much everyone in the world is running something similar to that on different scales, but the general structure is the same. And when you have people all around the world doing the same thing over and over and over, it's a bit of a waste. And the wasteful bit is that bit, the bit in the middle there, right? If you're writing something and you're a programmer, you don't care about any of that. You care about your users and you care about your code and how your users get to your code. You don't want to know how they do that, you just want to make sure they can, right? And that's just bloat. Because to have all that stuff introduces server management and DevOps, and you have security concerns, you have to keep everything up to date, if something falls over or something corrupts, you have to fix it. And that's, I don't know, me personally, that's not what I want to do. I want to deploy servers, and I never want to think about them again. And you also have to manage redundancy and all that kind of crap, and no one wants to do that. Unless you like DevOps, in which case this is not the talk for you. So this is the important bit, right? A web request comes in. Your code does something with it, and a result comes out. Right? That's the big picture. That's the big picture of any piece of software or a web app. And that is basically the idea of serverless compute, is something comes in, your code runs, something comes out. And it doesn't really care about how your code runs, or you don't care. It does all that for you. And there are no servers, but there are still servers, which is just fantastic. But you don't care about the servers, is the important part. I personally think serverless is a misnomer. I think it's a bad name for it because everyone, well, the first time I heard that, I went, no, that's not possible, that's dumb, and I didn't bother looking into it. You have to have servers. The idea isn't that you don't have servers. The idea is that the servers are not your concern. You pay someone some tiny amount of money on a huge scale, and they run it all for you. You just write code, and the code runs, simples. Right? I should probably stop and mention that there are competitors to AWS Lambda. I like AWS Lambda. That's the one I use. Google has cloud functions, which I've heard are very, very good. Azure has functions, which I haven't heard anything about. And IBM OpenWhisk, I had to Google to find. So whatever you like. But the idea is all the same. The idea of a serverless compute is something comes in, your code runs, something comes out. And we're going to use AWS. And the model for Lambda is very similar to that previous slide, which is great. An event comes in. Your code does something with the event, and a result comes out. Right? Easy. So what's an event? Well, an event could be me going into the AWS console and clicking a button to run the event. Importantly for us, an event could be a web request, but an event could be a ton of other stuff. So Lambda was originally created not for web apps. It was actually created because every man and his dog was making software that would, say, want to generate thumbnails of an S3 bucket. And everyone would implement that as every second, poll the S3 bucket for new files, then generate the thumbnails and put them somewhere else. And that was happening across all AWS services, people building these pollers to try and be responsive to events. And that's not great for AWS or for us, because we're all paying a fortune and they have to deal with all this wasted load. So yeah, originally you could do cool stuff with it. So their classic example is every time a file gets uploaded to an S3 bucket, generate a thumbnail, put it in a different bucket. Other cool ones are every time a record gets written in DynamoDB, do something with the record. Every time a push notification comes through, every time you receive an email, every time someone makes a Git push, every time you deploy a whole new stack, Even you can attach it to CloudWatch, and every time a new log message comes in from any one of your servers, you can do something with it. So if the log contains the word error, send you a Slack notification. And my favorite, Amazon Echo. I've got one. She's annoying as hell. Wakes up all the time. And that's really good and bad. Because if you've got a small to medium load, my rough calculations say if you've got an EC2 instance and you are running it over 50%, 24/7, 365 days a year, then Lambda is going to cost you more. But unless you've got that, unless you have 50% utilization, 24 hours a day, 365 days a year, Lambda is actually cheaper. And for most businesses, the real cost isn't in the server costs, it's in paying someone to manage them and update them and all that. So it can actually be quite cost effective, which is great. And the other important thing is it scales infinitely, because of what it does, where you put your code in, every time someone makes a request or your code needs to run, it checks whether or not your code is already sitting there idle in a tiny little Docker container, essentially. And if it is, it reuses it, so it's really fast. If it isn't, it makes another one. But that's great, because if you have no requests coming in, it's 6:30 in the morning on a Sunday, then all your containers don't exist. There's nothing. Whereas if it's peak hour and you've got 100 requests a second coming in, it will have 100 of them sitting in parallel, just churning through requests, and when peak hour dies down, they'll all disappear again. And you don't know how that happens or why, and it doesn't matter. Downtime doesn't cost you anything. So I'm sure all of you have personal websites or some little thing you've made at some point that doesn't have a huge load 24/7. I certainly do. And you are paying every month for a VPS, you're paying $5, $10, $20 a month for a VPS that I want to optimistically say 90% of the time is just sitting there doing nothing, right? It's waiting for requests to come in. And you are paying hourly for something that really doesn't provide any value per hour, it provides value per request. And that's a big thing, and that's the CTO of Amazon and AWS, that was his big spiel for Lambda, was their business model for AWS is they want to charge you for the things that cost them money. And that's how every business should be built. You do something that costs you money and you charge someone for that. You don't have all these costs that aren't associated with you making money. So if you have 10 views a month or 1,000 views a month, you're still paying the same for your server. Your costs don't scale with your income. So using Lambda, if you have no requests for an entire month, you pay $0.00. It costs you nothing, absolutely nothing. You don't even pay to store your code, it's just free. And optimistically, it can't fall over. Any code could fall over if you just write, raise in there, but it can't fall over in the way a normal server could. It doesn't get overloaded and then your Nginx crashes, and regardless of your code being perfect, something else fails. Sure, if your database can't keep up with Lambda, then it's going to crash. If you didn't, request a service limit increase, don't laugh at me. That's definitely not what happened to me. If you don't request a service increase, and yes, Lambda can run out of space. But if you keep requesting service limits, Amazon is quite happy to push you up to 1,000, 10,000 concurrent executions. So there are some cons. Everyone loves some odd language. Everyone loves Haskell and Clojure, and I don't even know. God, people like writing lol code or whatever that is. You can't run that, or you can, but don't. It natively supports JavaScript, Python 2.7, Python 3.6. There's a few versions of JavaScript. Java, C#, and there's one other one I always forget. What? No. Jesus, no. No. No, there's one other. But yeah, those are the important ones. And if you're not using one of those languages, you can actually still run your code on Lambda, but I wouldn't bother. You have to compile the whole language and put it in with your code, and it's not going to be worth it. But I'd say the majority of web apps that are new and modern are probably written in Node or Python or Java, or C# if you're crazy. And that should cover most of the market. The other issue is that it can be tightly coupled. So if you write code that only works in Lambda, it's only going to work in Lambda. You can work around that, and obviously with any piece of software, you can design it to be compatible in any way you want. But the demo I'm going to do today, you couldn't even run on your local machine. You'd have to write a wrapper to pretend to make a Lambda event. Like, I can't run this. I haven't tested it, so that'll be fun. And the last downside of it is warm-up time. So warm-up time is the time it takes if there are no idle instances available, and someone sends in a request, it has to make a new container, put your code in it, and run it for the first time. That takes time. That takes about a second, which for most things is okay. But if you're running, say, a real-time API, and it's the first request of the morning, and your user has to wait 1 or 2 seconds for the first instance to spin up, or as you scale up, every user has to wait a second because every user is creating a new instance, that can be really bad. But if you have a consistent workload through the day, your response time is going to be 20, 30 milliseconds. It's not going to be a problem. Cool. So if Lambda runs with events, and it's an event-based system, how do I take a HTTP request? That's not an event. That needs a server, right? So we use API Gateway. So API Gateway is another AWS service that does basically that. It takes HTTP requests, turn them into events. And it's also, you pay per request. So there's no ongoing cost. This sits here 24 hours a day waiting for requests, but you pay like 20 cents per million requests or something like that. And it manages all your HTTPS, your SSL certificates. It does everything for you. It can even do much more advanced stuff than we're going to do today. You could have different routes, say like API v1 goes to this, API v2 goes to this, even down to the idea of you could have every endpoint in your API being its own Lambda function or its own EC2 instance. You can do some really cool stuff with it, but we're not going to cover that. So it's a gateway, as the name suggests. And one of the important things about Lambda is that unless you go into the AWS console, there's really no way to just run it, right? You need something to run it. So API Gateway does that. And this is my favorite setup, where you have a VPC, which is basically a big virtual private cloud, a security bubble all your stuff exists in. You've got some databases, you've got some EC2 instances, you've got your Lambda functions, and you build gateways between them. So you build an API gateway which has a structured interface of what is allowed to come in, where it should go, and what the response is going to look like. And it's a great way to provide security to all your stuff, because no one can just enter into your database. And the other benefit of API Gateway are these little doodads down here. These are SDKs. So if you use, say, Swagger or any other way to explicitly define your API in API Gateway, and you define in advance what your acceptable routes are going to be, API Gateway for free will actually generate SDKs in like 20 languages or something for your API that people can just plug and play. Not 20? Oh, okay. I was going to say, I think it's about 20. I think it can generate. So if you define your API in advance and you say, these are the routes, with a couple of clicks, you can download and automatically deploy even to your website all these SDKs. It does versioning for you. It does everything. It's really, really, really nice. So combining the two, we get this beautiful structure. User makes a HTTPS request. API Gateway receives it, validates it, blah, blah. And then it does what's called invoking. It invokes the Lambda function with a request, an event, which represents the request. API Gateway then waits for Lambda to do its computation, to render a page, render a JSON blob, whatever it's doing, or even do nothing. Might just, write a log and then do nothing. Lambda function returns a response to API Gateway. API Gateway turns that into a HTTP response and sends it back to your user. And the user's none the wiser as to what's actually happening here. And recently, API Gateway has had this fantastic idea for a Lambda proxy. So, like I said earlier, Lambda wasn't actually invented for this kind of stuff. It was invented to stop people polling S3 buckets and polling DynamoDBs 24 hours a day trying to wait for updates. And when they first introduced it, there were some issues with it. The only way you could have API Gateway do Lambda functions is if you did what I said before, how you explicitly predefined every single route, every single method, and manually mapped every method, so get, post, options, everything on every possible route individually to a Lambda function. And for each one of those, you also had to define how it should package up the requests into an object, then pass to your Lambda function, and when the Lambda function returns, how that return gets turned into a HTTP response, which was just awful, and it just made this so unwieldy, and it was impossible to use unless you wrote command line tools to generate it for you. So what they did was added Lambda proxy. They came up with a standard, and I thank them on my knees for it. It is beautiful. It's a standard of what the object looks like going into your Lambda function and what the object you should send back looks like. And it's really, really nice. It's very, very simple, but it covers everything you need. So for API Gateway going into Lambda, I'm going to do a demo, show you what that looks like, because it's too big to put on a slide. So this is a Lambda function I have running behind API Gateway, and all this function does is prints out the event as a JSON blob. And importantly, you can see a lot of information in there. Probably shouldn't show you that one. But the rest of it is, so you can see here's my query string parameters. So I chucked in some stuff about A equals 1 and B is 2. The method, this is stuff to do with API Gateway itself. all my headers, my path, everything you can want. And you can even upload binary files into Lambda, and it base64 encodes them and sends them to you as a string, which is a very recent update. So everything you would want, right? Everything you'd want for your web server. And then all you have to send back is this. So it wants a response in Python. It'll be the same in any language, which is a dictionary with a status code, which a body, and an array of headers, or dictionary of headers. And that's it. That's all you need to do. And with that, you can write really simple code. And I've paraphrased Tom here, and I'm going to do a demo. So, so this is something I wrote last night. And what we're going to do is copy and paste that code. And you can see the Lambda handler there is the main important function there. You can call it anything you want, but the default name is Lambda handler. And it takes two arguments, which is an event and a context. The event is your HTTP request. The context is to do with if you run your Lambda function inside something else in context. And you can see out of that, I've just got basically done nothing with the root event, and I'm just going to spit something back at you as a return. So we're going to open up AWS. I am going to log in, which I thought I did before the talk, but it's kicked me out. Oh yeah, on my laptop too. So AWS console. Who uses AWS? Like, is there anyone who has never used AWS before? This is the AWS console. This is all your AWS products. They're really cool. Try them out. Their free tier is really, really good. So we're going to go into compute, and there's Lambda, which is still unreadable up there. Right, and these are my Lambda functions. Probably don't care too much about them. And what I'm going to do is make myself a new one. And zooming in was a bad choice. So I'm going to make a blank function. And I'm going to skip this. This is if you want to use S3 or DynamoDB or any of those things I was talking about. You can just click on that, and it'll ask when you pick the product you want, and then you pick the trigger that wants to make your Lambda function run. So we're going to ignore that. We're going to set up the other way, where we make the Lambda function first and then connect the API gateway to it. But you can do it in reverse. You can create your Lambda function and then tell it to make the API for you. So Lambda function next. Pick your, give it a name. I'm going to call this UQCS. I'm going to pick my runtime. Oh, here's the one I missed. Oh, there you go. No, I didn't miss one. There's just lots of versions of Node. So yeah, C#, Java 8, 3 versions of Node, 2 versions of Python. I'm going to do 2.7 because I suck at updating. And we're going to paste in my code. And importantly, my code doesn't use any external libraries. It's using built-ins. If you had external libraries, all you do is put your code in a zip and put the libraries in there, in the zip. And here, instead of choosing edit code, you just go upload a zip. And that's it. You put your code in a zip, send the zip off, and it runs. It's really, really easy. And behind the scenes, when I hit save here, it actually will always use zips. So it's going to put my code into a zip for me and just store it somewhere. And that's it. So I'm going to create a role. AWS has these concept of roles, which are sort of pretend users. I don't want to call them that, but you can give them permissions. So in this case, my code doesn't need any awesome permissions. It doesn't need to write to a database or anything. So I'm going to give it a new role, which is just going to be called empty. And I'm not going to give it any policies or anything. And the last thing I can do, which doesn't matter here, is I can pick how much memory I want to give it. So some of you might have been wondering that. How much power do you get in a Lambda function? So Lambda is useful for a lot of things. It's not applicable for some things. You pick the amount of memory you want, anywhere from 128 meg to a gig and a half. And your CPU credits, the amount of CPU power you get, scales linearly with the amount of RAM you pick. And basically, when you end up paying for it, you pay for gigabyte seconds. So if you give a Lambda function 1 gigabyte of RAM and it runs for 1 second of time, you pay for 1 gigabyte second, which is about 1 millionths of a dollar or something. So in this case, I'm going to put in 128 meg of RAM, which is plenty. How long I want it to time out. If it goes longer than 3 seconds, it'll be terminated. The longest you can let it run is 5 minutes. AWS will not let you run a Lambda function for longer than 5 minutes. But to spite them, Google's limit is 5 minutes and 10 seconds or something like that. So I think they're just going to keep fighting upwards. So at 128 meg on the AWS free tier, which on Lambda is actually free forever. It's not a 12-month free tier. It is a forever free tier. if I give my function 128 meg of RAM, I get something like 20 million seconds of compute time for free, which is crazy. And that will never ever die. So I'm going to run that, hit next, hit create, and it's going to create my function. It's zipping up my code, deploying it to the Lambda services, and importantly, it's distributing it across all the, what are they called, availability zones inside Sydney. So even if one of the AZs go down, which does happen, Lambda will not fall over. My code is deployed in all 3 Sydney AZs, and you can even use more advanced services to deploy your code into every AZ in every location around the world and have different API gateways than use DNS. So your code actually runs where your users are instead of running where you are. But my users are all in Brisbane, so Sydney's good for me. And that's it. So my Lambda function now exists. I can click test. I can tell it what I want my event to be. For me, I don't care. It doesn't use anything from the event. And I can save that and test it. And I can see that it returned a dictionary with a body. Can everyone see that? A body, a dictionary of headers with a content type, and a status code. And that's it. So far, so good on the live demo. So we're going to go to API Gateway, which is the service that does this kind of stuff. I'm going to make a new API, and I'm going to call it anything UQCS. I'm going to create that. And cool. So API Gateway is structured as a almost RESTful, I guess. You create resources. Resources have methods. So a resource could be /cars, and methods could be get, which would get cars. It's very structured like that. So for my root, I'm going to add a new method, and they have a magic method called any, but you could pick anyone you want and define them all individually. Any, and I'm going to say that any is this new Lambda proxy. So I've set it to Lambda function using the proxy. It exists in AP South 2, and it's called UQCS. Cool, and it's asking me whether I want to give API Gateway permission to run my Lambda function, which I do, otherwise I don't know what would happen. Probably just fail. And here, for this API, I would be done. This little example I made doesn't have any extra paths. If you go to, if you go to blah.com, it shows your page. If you go to blah.com/something, it still shows you the same page. It doesn't care. So just for demo, we're going to make a new resource. And they have this beautiful thing. If you're using something like Lambda, you can make a proxy resource instead of defining everything individually. And the proxy resource is just a wildcard. It will match every request that ever comes in from any route, which is great. And so I can create that, and it will ask me what I want to do with it. It's automatically made me an any, and I want that any to go to a Lambda function inside AP Southeast 2 called UQCS. Cool. And yes, I want to let it run. And that's it. I can now click deploy, give it a name, anything you want. This will come up as like API name /route. So you could call it v1, v2, dev, whatever you want. Doesn't matter for us. I'm just going to call it dev. And I click deploy. And that's it. We're done. I now have a link here. If I click that, it's going to make a request to API Gateway. API Gateway is going to pass that onto my Lambda function. My Lambda function is going to hit the Slack API and get the messages out of the channel I gave you at the start, render that into some HTML, and then it's going to send that back as a response. And that's it. So with that tiny little amount of thing, and that cost me 2 billionths of a cent or something to run that page, with no servers, no setup, no waiting for VMs to create, no apt-get update, I have made a website that is live and anyone in the world can open it up. So from here, it's basically done. No, I'll refresh it. So you can see that first load took maybe a second because it had to spin up. If I refresh now, the only overhead should be the time it takes to load from the Slack API. Tom joined the channel. Cool. So what's wrong here? What's wrong with this? This could be a website, except I don't want to write on my business card ec2u73 blah blah blah.executeapi.amazonaws.com. That's awful. And I also don't want, if this is my website, to make people have to type in /dev every time they open it. Because if I just go to that without the dev, I will get a forbidden message. So that's pretty useless, right? So recently, thankfully all this stuff has just come into fruition recently, which is why we're doing this talk. AWS now has a support for custom domain names, which they've always had, but even better, they now have support for you using Amazon Certificate Manager, which provides free SSL certificates to you, and they last a very long time, and all you have to do is one-click updates, and it updates them and redeploys them across all your services. So it's all the good free bits of Let's Encrypt, but it's actually managed for you, and when you update it, it deploys and distributes itself, which is really handy. So from here, you can create a custom domain name, anything you want. You can attach your certificate to it, and then you add a mapping that when the user goes to, say, empty, send them to my UQCS API on the development stage. So you could map, I want to use a bad example, but I can't come up with it. For work, dev.polymathian.com is mapped to this API's dev release, and prod is mapped to the prod release of this. And you give that, it will spin that up for you, and you just paste the text it gives you into Route 53. So if you want to play with the thing I've made one earlier because I'm a fantastic chef, and you can access that at slack.grice.net. Please don't kill it. I don't know what the rate limit is on the Slack API, but every request you send it, it forwards onto the Slack API. Cool? Cool. So what do you do from there? Well, Lambda does more than that. I like web apps. That's what I do every day. I like web apps. Web apps are great. You can do more. Like I said, you can, every time someone uploads a file, do something with it. CloudWatch, something we're going to start doing at work, I believe, is log streams. So AWS has support for Kinesis streaming using, I don't want to say Firehose, just Kinesis streams. You can pump all your logs in one end, and you can attach a Lambda function to the other end, and it will scale up and down the Lambda function to process the logs as they come in. Really, really handy. And you can analyze that, do whatever the hell you want with it. Process items off a queue. If you use Simple Notification Service or Simple Queue Service, you can attach a Lambda function to it. So you could build a system where jobs go into a queue. So you've got a website where people can turn PDFs into Word documents or the other way around. You put that item into a queue. The job gets picked up by a Lambda function. When it's done, it puts it back on another queue, and then that Lambda function returns it to the user. And you can chain these together. You can do really cool stuff where you have a queue, starts a Lambda function, that Lambda function puts something else on a different queue, and you can chain these all together, and that's how you get into microservices, where you've got these really tiny bits of code that each do one specific thing really well, and when they want to do something else, they pass it off to a different function. And that's really, really handy. And one I've used before, and one I have running all day, every day, is I have an email address that I don't like, and I have a Lambda function that every time that address receives an email, it processes it, looks for spam keywords, runs it against a spam filter, and if it's good, then forwards it on to me. I use it to sign up to crap. And all of these things can be done without writing a poller. You don't have a server that is sitting there polling AWS 24 hours a day, waiting for updates, costing you money for the server and money for every request you make, because AWS charges you for every little thing you ever want to do. So it's really, really good. So I recommend everyone try it out. I'm going to put up the code for that without my token in it, and you can run it yourself. You can do exactly what I did here. You can make a Lambda function, paste it in, and it should run exactly the same. You can make an API. One of the harder things with Lambda, or one of the easier things with Lambda, is when you just return text, you can just make an API straight up. If you want to start involving libraries, you have to figure out a way to put those in, because those libraries depend on other libraries, and putting them all in the zip together can sometimes be a difficult thing. There are libraries, again, that will do that for you, but you have to find those. And a really good one I can recommend for Python that we use at work is Zapper. Zapper is a fantastic library. What it does is you write a Flask app in Python, and it will turn that. You just go Zapper deploy, and it turns that, it puts a wrapper around it and puts it in Lambda, hooks up API gateway, and hooks up your domain for you. And basically your Flask app gets deployed as a serverless web app, and you don't even know how. You just write a config file. Some open source ones, blow my own horn here. UQ Finals API is entirely run on Lambda, which was great because the first day I deployed it, someone decided they'd see if they could kill it. 60,000 requests in half an hour, and it cost me 12 cents to deal with that. And nothing fell over, and I was very happy. I've recently tried writing a blog in Python that's open source. It's awful, but it is very, very simple, and that's the important part, is you can look in it and you can see how I'm splitting out different routes, how I'm doing pages, and it also integrates with DynamoDB. And the last thing I can recommend is there's a channel in Slack called Cloud, where it's, I guess, the channel for this. I'm going to archive the serverless channel, so don't stay in there. And the Cloud Channel is a great place to talk about all of this, talk about issues you're having. There are definitely, as you try and do more and more complicated things with Lambda, things that will crop up, like when your library relies on a binary component, like in Python, how some parts are written in, what are they written, Fortran, C, that kind of stuff. And they can cause problems. And there are fantastic resources out there, but sometimes they can be hard to find. So if you run into an issue, chances are someone's had that issue before. Cool. So I think that's the end of my slides. And yeah, I hope I've piqued everyone's curiosity and explained a little bit what serverless is and that it's not actually not having servers. Hopefully people will try and make something out of it, but otherwise I hope it was interesting, and thanks for coming.